I don't see the timer on YouTube for some reason. Ah,
You see it now?
okay, we're live now. Welcome everyone who's joined. Let's give it maybe 30 seconds before we get started to allow more participants to join in. We see a few highs on the chat, so hi everyone.
Hey guys.
Okay, I think we should get started without any further ado. Yeah, I welcome everyone again to this webinar that we are extremely excited to present to you. As the title suggests, it's the automating the first hour of troubleshooting, and we have with us Sham today, who's our VP of Product and Strategy, and I'm Satya, uh, also in the product team, heading product, but also the Chief Business Officer. If you were worried, I'm only the Chief Business Officer and not going to cover technical topics. Unfortunately, I will also be chipping in. Uh, I think we are all set to go. We have a number of participants already watching us live. I'll hand over the presentation to you, Sham, so you can get started, and I'll be monitoring the chat. So if there are any questions that come in, I'll point it out, and we can take questions as and when they come in. Over to you,
Sounds good.
Sham.
Thanks, Satya. Welcome everyone to this webinar. So we are going to be talking about how you can automate the first hour of your troubleshooting. So when you have incidents and when you're working on them, what can you do to make that initial difficult bit easier? That's going to be the content of this webinar. So let's talk a little bit about the pain first. The pain that comes with that first hour of incident response. There's various different things going on at that point in time. So just think about the experiences that you've had when you're got that alert notification or that pager or that call in the middle of the night, and you need to troubleshoot an outage, or there's something going wrong and you need to figure out what it is, or you're on call and now it's on you to sort out the mess. So there's different challenges that come up during this point in time. We'll cover some of them, but this is not an exhaustive list by any means. Data fidelity is often one of the challenges and one of the hidden challenges where you don't realize it until it's too late. Because if you're sampling or averaging or aggregating out metrics and you see a chart, but you're not seeing the full picture. So if, for example, you have aggregated 60 seconds worth of data into a single data point, then your chart could be showing a perfectly flat line, but inside of it there could be all sorts of peaks and dips that are happening that you're just missing. And when you're in the arena trying to troubleshoot something live, that's when data fidelity is the most valuable. And when you don't have it, it makes things a lot harder. It's like trying to solve the problem with your hands tied behind your back. So data fidelity is of utmost importance during that first hour of incident response. The second item here is context loss. So you might be getting signals from different tools, from your metrics, from your logs, from your events, across uh, different kinds of tools that you're using in your infrastructure. But sometimes what happens is that the context behind it gets lost. So you don't have the full picture in terms of the relationships between different metrics, or is what you're seeing for a specific metric, is that normal, is it abnormal? You don't have that context at all times. And again, this can be very worrisome because while troubleshooting something, you might be looking at different charts, different graphs, and you might be seeing certain patterns, but you need to know whether that pattern that you're seeing actually means what you think it means, right? So if you see a spike, you might be thinking that, oh, maybe this is the reason. But you need to know that the spike, is that a regular occurrence on the system or not? So that's part of the context, and there's a lot more what I mean by context around it in terms of the metadata. Are you aggregating the data properly? Are you visualizing it properly? All of that kind of gets tied into the context. And then on the third box, you have the cognitive load. So this is again a very common issue where you have too much data. So you have thousands of metrics, hundreds of charts, alerts, logs, everything. And then at that crucial moment in time when you're troubleshooting something in the middle of the night, it's way too much, right? So you don't have enough time to look through all of the data, and you are very aware of this fact, and that causes stress. And to add to it, you have time pressure, right? Because every second counts. You just need to recover things as quickly as possible. In many cases, you are not prepared for this at that moment in time, either physically or mentally. And the time pressure just makes things a lot more challenging, which means that you need to be able to get to what you need to in as easiest and quickest and simplest a way as possible. And then we have trust gap. This is something that's becoming more and more of an issue, or of a thing that the teams should be concerned about, especially with AI systems and machine learning systems. If those systems are a black box to you, how do you build confidence? How do you decide that during crucial times that you can trust the output that's coming out of it? And then finally, the signal versus noise conundrum is something that we see all the time. There's a lot of data. How do you find the most relevant bits of information from among the deluge of all of that data? So it's about how quickly you can find the needle in the haystack. So this is where, of course, Netdata AI comes in. This is what what we've been building for a while now, and what we continue to improve. Practically every week or every other week, we've been adding new functionality to Netdata AI. So if any of you have tried it out in the past and haven't looked at it in a few weeks, I would highly recommend taking a look at it and giving it a spin. I hope you'd be pleasantly surprised. So with Netdata, the way that we implement AI and machine learning is in two layers. So we have it both at the edge on your devices and in the cloud. So what this means is that on the edge side of things, on your Netdata agents, we're running unsupervised machine learning on the per second data that's being collected on every single node. So this is your anomaly detection, which we use for showing you the anomaly rates, building the anomaly advisor, and so on. But the fact that that's happening on device and it's unsupervised means that it's training these models in real time on your data on each of the nodes means that it can actually adapt a lot more than something that's running in a central location or in a cloud somewhere would be able to, because this exact same value for the exact same metric on one system and another system could mean two completely different things. So this is why the edge layer is really important. And then you have the cloud layer. So this is what's built in Internet Data Cloud. So here we have the ability to query and make sense of all of the data that's stored across all of the Netdata agents. And we rely on state-of-the-art large language models. We'll talk about the kind of models that we use to be able to make sense of all of this, to synthesize all of this, to be able to correlate metrics and logs and events and alerts and all of these different things, and then to reason over it in kind of a multi-turn agentic manner to be able to prepare a very detailed troubleshooting report or a root cause analysis or a postmortem, an alert troubleshooting, a capacity planning document, any of those things that you might want to do. We will be focusing especially on the troubleshooting aspect for this webinar. So this system kind of is designed to, on one side, provide high fidelity data which is enriched with information about whether this is anomalous, whether it's not anomalous, how the correlations are looking. And then on the other side, you have this advanced reasoning capability that can actually make sense of it, which can actually learn how to use the tools properly to navigate Netdata Cloud's query engine. And what we're hoping that you would be able to achieve with this is that you can use the system to reduce the amount of time that it takes for you to root cause and troubleshoot and resolve outages and incidents from hours to hopefully a few minutes. So let's talk a little bit more about layer one, which is intelligence at the edge. So what does this mean? So on the one side, it means per second telemetry. You need to have data that's available per second. And we'll talk a little bit more about why this is very crucial for all observability systems ideally, but especially for the ones that have AI capabilities built into it. But per second telemetry is crucial. And then on top of that, we have the unsupervised anomaly detection, which means that the unsupervised bit is also really crucial here because you don't have to do any customization, any configuration, and you would still be able to get anomaly detection models that are being trained in real time on your data, on your systems, thousands of them that are just happening automatically that you wouldn't need to worry about. But what they're able to do is they're able to capture the behavioral patterns of every single metric across all of your infrastructure. And then it's about the metadata, right? So what kind of metadata that can you provide along with the metrics? I would say that the anomalies detection metrics are kind of a metadata. It provides additional context about the metric. Is this anomalous? Is this not anomalous? But there's a whole lot more metadata that you can have along with the metrics in terms of where it's coming from, how is it being collected, how often is it being collected, how is it being aggregated, how is it being visualized. All of that kind of falls into this. And then finally, any intelligence that you're trying to apply at the edge has to be very lightweight. So these unsupervised machine learning models that we're training and we're using for inference have to be extremely optimized. You shouldn't be seeing spikes in terms of your resource usage just because anomaly detection is running. Because if you do get a resource hit, that means that you're going to take the choice to turn off or turn on these things as and when needed. And that sort of cherry picking will mean that you don't get the full benefit out of it. So we spend a lot of time and put a lot of effort into ensuring that uh, the machine learning that we do on the edge is very, very lightweight. And I think that philosophy applies for anything that we do on the agent. And then we have layer two, which is reasoning in the cloud. So we use state of the art reasoning models like Anthropic's Claude 4.5, OpenAI's GPT-5, and other models as well. So what we've done is we've built this sort of system where you can have multiple different LLMs, and each of them picks up the task based on what kind of task it is and what that particular model is good at. We don't want to rely on just one model that will do everything. And we found that this works even better. So you could have, for example, you could have a controller model that has many other models reporting to it, and it could assign different tasks like log analysis to one model, metrics correlation to another one, similarly. So I'm just giving a random example, but that's the kind of thing that happens. And all of these different agents would then work in parallel as different workers, and then kind of pool the information analysis that they've done together. And then you would have, let's say, a report generation model that would be tasked with making sense of all the data and then analyzing it, creating a further report. So a lot of, let's say, independent actions kind of go into each troubleshooting step that you would see in Netdata AI. This also means that we can do cross-system correlation, you can do pattern recognition, you can do forecasting, all of these things at the cloud layer, because you have access to all the data from across all of the different parts of your infrastructure. And you can always query just the amount of data that you need. You don't need to store all of this in one central location. You only query it as you need it, do your analysis, and then discard the data. And of course, we're doing all of the actual synthesis, the generation in human readable natural language formats, so that at the end of the generation, what you get is either an incident brief, a troubleshooting report that's, of course, it's readable by you, but it also has citations, in the sense that it's bringing the metrics from, it's bringing the relevant charts, it's bringing the relevant logs into that visualization, so that you don't have to just believe the report when it says something. You have the evidence right there, and you can interact with the chart, you can interact with the logs, and so on. That's the idea.
Sham, we have a question,
Sure.
and I think it's a question that many of our customers ask from us, and it's something that we're happy to explain here. Let me put it on the stream.
Sure.
It's a question from 74C Monty. I would love to know the real name. So, what do you reply to your customers who are concerned to share their data with Netdata Cloud? Or can the cloud layer with LLM, etc., run in a hosted, self-hosted environment?
Yeah, it's a great question. So what as of now, we are using AWS Bedrock to host some of the models that we are running. And what this means is that it's also an opt-in feature, right? So we have the feature. If you want to use it on a data cloud, then the data in an anonymized manner is being shared for LLM reasoning. It is not used at any point in time for training LLM models of any sort. But on the other side, if to your question about the self-hosted environment, this is something that we're actually working on right now. We're exploring different, because we've had this question from many customers recently about wanting to use Netdata AI features in in a on-premise or a self-hosted environment. Some of our customers use Netdata Cloud hosted on-prem, and this is something that we're evaluating on how we can make this work. So, like I said earlier, you can have different LLMs to do this task. We're running some tests internally to see if any of the open source LLMs are actually currently capable enough to do a really good job, like the models that we're using. Um, if and when they are, of course, we'd be very happy to provide um, kind of a, let's say, an LLM inference server as part of your self-hosted Netdata cloud, and you can do local inference in that case. Another option would be if you're using if you're using AWS, and if you're already a customer of AWS Bedrock or AWS in general, then you could use Netdata and Netdata Cloud completely self-hosted, but then rely on the AWS instance that you're already using for your other material, right? In which that's also an option that you would have.
Maybe I can add a little bit more just to make it more clear. So, first thing is customers concerned about sharing their data with NetData Cloud, just to make sure NetData Cloud does not store data. It's a fully distributed architecture. So the data actually, stays on your premises in your infrastructure, no matter which solution or which offering of NetData you use. Of course, if it's about sharing data with the LLM, yes, so Netdata does use some of the right state-of-the-art LLMs using AWS Bedrock. But like Sham mentioned, we do intend to provide this capability for our fully self-hosted on-prem customers, either through bring your own API option or even use Netdata AI as a service. But it's something that we will definitely keep you guys informed on. But at least for the data aspect, just to make sure everyone is on the same page, Netdata Cloud does not store any data. It queries the data on your infrastructure. It puts, let's say, the summary together, and the LLMs don't get that data to train their model.
Yeah, thanks for adding that, Satya. And I would just say that we take data privacy and data security very, very, very seriously at Netdata. And we've recently got our SOC 2 attestation. So if anybody would like to see more, please check out trust.netdata.cloud, which is our new Trust Center page. It talks about all the different systems that we have in place to protect customer data. So the next section is about building trust in the output that you're getting from the automation, right, from the AI. So how do you avoid the black box problem? So there's different things that you could do as part of this, and different things that different kind of systems could put in place. So one obvious thing is, of course, citations, source linking. So if you say that something happened to a specific metric or a group of metrics at a specific point in time, can you bring the receipts, right? Can you bring the chart? Can you show what you're talking about so that the user can then see it together and then make sense of it? So whenever you see a chart or some real data like logs that's embedded into your AI troubleshooting report, that's always just taken from your regular Netdata dashboards. That data has not been, let's say, created or generated or synthesized in any manner. It's just a regular chart that's been moved into the troubleshooting report so that it's easier for you to make sense of it. The other thing is, of course, the anomaly scores that we always try to rely on when it comes to troubleshooting reports. So it's not just that the AI reasoning, the LLM is saying that this is weird or this is something that shouldn't have happened. It can always look at the anomaly scores to get that information. So, the AI might see a CPU of 95%, but then if your anomaly scores are saying that this is not an anomaly and the system is always between 90 to 97% CPU, then your 95% CPU spike is not something to worry about. Similarly, the other thing that we try to do is to provide confidence levels. So when we provide, let's say you're trying to troubleshoot or root cause a problem, Um, Netdata AI will provide you with a hypothesis or with next steps, with um, what could the potential problem be. We try to provide confidence levels alongside. So it might say that I've identified three potential root causes for it. Root cause number one, this is the confidence level high, or we are 70% sure that this could be the problem. Root cause number two, we're 50% sure that this might be the problem. It's again intended as sort of a device that you can use to decide what to focus on, or how sure understand how sure Netdata is about whatever troubleshooting analysis that we've just done. And of course, the raw data should always be available for your analysis. So you can always rely on that. So the idea is that agency in terms of what step to take rests with the engineers, and the AI is assisting, and it's not deciding for itself. Um, the AI should provide you the information, and then you can take the call on what to do. Um, the the other thing that you could always do is, it shouldn't, of course, one of the very common problems that you hear about all the time is hallucination. So we've spent quite a lot of time and effort, I'd say, in making sure that the Netdata AI troubleshooting reports don't hallucinate. Of course, hallucination is not a 100% solved problem anywhere in the industry, but I think we have enough checks and balances in place that um, the reports that you generate, in most cases, in 99% of the cases, you shouldn't see something that's completely out of the ordinary. It's always going to be data backed, evidence backed, and then you will have access to the evidence right there along with the report, so you can make the call for yourself. And then kind of segueing from that into how do you interpret AI findings. So there's a few tips that you could do. One is start with the timeline. So the AI reports, for the troubleshooting reports, usually talk about a timeline of the issue. This is when that happened, then this happened, then this happened, and it gives timestamps. It's been giving it in UTC so far, where we've recently working on a way to kind of make it so that it just does it automatically in your time zone. So it's easier for you to kind of form the mental picture. And then you can check the anomaly scores that have been reported, and you can cross-check it with the anomaly scores that you see in the charts. You can look at the chart information, the citations, the logs, things like that. Does that support the claim that the AI is making? Of course, cross-referencing with your domain knowledge is something that you're going to be doing anyway. And then finally, treat the hypothesis as a hypothesis, right? It's AI is not an oracle. It's not going to be able to predict what exactly happened, but it will be able to provide very good, very relevant, and very likely hypothesis, and you should treat it as that. So the idea is that you take your expertise, you take the automation assistance from the AI, and then you get much faster resolution times. So I would say it's also um, it also comes with experience. The more you work with the tool, the more used to you are to how to get the best out of it. So for the next section, I think I'll hand it back to Satya.
Thanks, Sean. Okay, I think the entire industry has jumped on the AI bandwagon, which means all observability solutions are also moving in with the whole agentic AI and AI-based observability as expected. But there are a few differentiators that basically means that the troubleshooting assistance that Netdata provides is going to be superior to other solutions out there, and we have very quickly kind of summarized some of those. So, Sham, if we can move to the next slide. And all of these are to do with Netdata's value props. So first differentiator is granularity. As all of you know, Netdata collects every metric every second, and that is a key differentiator. Let's look at it, right? So assuming another solution kind of collects data every 30 seconds or 60 seconds versus the data being collected every second. What this means without AI is that you can miss transient issues. And I think this is more and more relevant with the microservices based infrastructure, where things are changing in milliseconds, if not microseconds. So if you only have data that is collected every 60 seconds, means you are going to miss transient issues. Even so with the 1 second, but I think that's as close to real time that you can get. So these solutions which collect data every 60 seconds are going to aggregate the data, average them out, which means that the real truth is hidden. Now, when you put an AI layer on top of it, it means that AI actually has incomplete data to create a more meaningful analysis that will help your teams to find the root cause much quicker, resolve the issue, save time, and all of those things. So I'm not even going to the right hand side. It's pretty evident given that Netdata collects every single metric every second. We have more data, more granular data. So when you put an AI layer on top, uh, the analysis that it can go ahead and perform is way more granular and way more accurate compared to other solutions out there. The second one is coverage. I think most of you who are on this webinar kind of are aware of the entire automation or the auto detection and collect all the metrics philosophy of Netdata. So we don't sample in any way or filter in any way what metrics need to be collected. You install a Netdata agent, it auto discovers every single metric, whether that's system level metrics, application metrics, custom metrics even, and puts them on the dashboard. Now, this is the pre-AI era. And some of our customers, I think some of you as well on this call, in the past have complained there's way too much data. There's way too many charts on the dashboards. And maybe my team is not uh, efficient enough to take a look at all that data and make any meaningful sense of it. And that's where adding this AI layer on top, given that you have hundreds of thousands, in some cases even millions of metrics available on a per second basis, and then you put AI on top. I think Sham mentioned at the beginning of his presentation about the context. Now that is what happens when you collect everything. The AI now has a clear context of what's happening across your infrastructure, but also across different components like applications, network devices, you name it. And we have all that context. So when you request Netdata for a root cause analysis, it does kind of have a more or less end-to-end picture to finally give you some kind of a report, some kind of a summary that saves crucial minutes, hours, in some cases days, to resolve an issue. Last but not the least is retention. I think this kind of is an extension to the question that came in from 74C Monty about the data. So given Netdata stores all of the data on your infrastructure, it's not a centralized solution. So you store all the metrics, all the logs, and in the very near future, all the traces on your infrastructure. So you have full control of how long you want to store all of this data, whether it's weeks, months, even years. So just to give you an idea, with 3 gigs of storage, you can have up to 2 years of retention on metrics. That's how optimally Netdata has been built. So if you so intend, you can have all of your historical data on your infrastructure, and then the AI piece can even analyze trends, what's happening, over a period of time, and how your infrastructure has been changing, how your performance has been changing, and then provide, very meaningful recommendations on how you can optimize your infrastructure. I think with those 3 points, we move on to, I think, the most interesting piece, which is the demo. And at the exact time when we have a question from our audience on when we should expect the demo. So, Sham, all yours.
Okay, sure. Let me share my Netdata console so that we can jump into the demo. Share. I hope everybody can see my screen. So this is one of our test spaces where we're running all kinds of random things. And this is the Netdata AI tab. You can see all of the different reports that you can generate. You can see that we have alert investigations and troubleshooting as well. And for those of you who haven't noticed, you can also now schedule investigations and reports. So if you want to run infrastructure summary for the last 7 days, for all of your nodes, and what's been going on in your infrastructure, is anything burning, does anything need your attention? So it's kind of a quick way to get everything in one place for you to start the week. For the purposes of this webinar, we'll be focusing on the troubleshooting report. So for those of you who haven't tried this out, this is basically an open-ended investigation mechanism. You can describe what you want to investigate within the scope of your infrastructure here, and provide any kind of context that you want to that's related to that investigation. And then Netdata AI would go off, take 2 to 3 minutes, and then come back with an investigation. It might, in some cases, ask you for a few follow-up questions if it doesn't believe that it has enough context. These are just some of the examples that we've listed to kind of make it easier for you to understand what kind of things that you can ask it. But there, by no means is this like a limited set. You can ask any kind of thing that you want. I'll walk through two specific cases, just so you get a picture of the kind of investigations that you can do and how do you make sense of that troubleshooting report. So let's look at the first one. So this is an already generated report. If you want to know what was asked to generate this, you can click on this information button here, and it'll tell you this was the question. Can you create a report analyzing the performance of my Postgres server? I want an analysis per database. This was what the question was. And below it, you can see a generated description, which is basically what Netdata AI takes the question that you asked, and then it kind of builds on it so that for all the AI workers, they kind of have more context on what kind of things to do. So it's already kind of made the single line question into a paragraph with more information built in. And this is what the output looks like, right? So you can see that there's a summary, there's a query performance analysis. We're looking at connection utilization, buffer cache efficiency, database storage growth analysis, and then we have some recommendations at the end. So let's kind of walk through this report, this particular Postgres performance analysis. So what are we saying here? So we're saying that the Postgres infrastructure is running on a data parent latest, which is a parent node. It's monitoring 18 different databases with total storage footprint of 3.2 gigabytes. The instance demonstrates exceptional performance, near perfect cache efficiency, optimal query response times, and healthy resource utilization patterns. So you already kind of know that you're in a good space. There's nothing burning at the moment in this particular setup. Yeah, go ahead, Satya.
Sham, I think the font is too
Oh,
small. Maybe it'll be good to zoom in.
let me make it a bit bigger. Yeah.
Finding it difficult to read it. Hopefully,
Is it,
it's better
is it
now.
better now?
For me, yes.
Okay.
But yes, I think we can proceed.
Okay. And then what are the critical findings? So in this case, there weren't any big red flags. So it's saying that cache performance is great. So is query performance. We have healthy connection usage. What are the immediate action items? We could implement an archiving strategy for the chart database. So this is one of the 18 databases that we're running. It's occupying 75% of the total storage. This is why this has been recommended. We need to monitor log contention in another database called alarm processor. There's 12 to 14 logs being held consistently. We need to investigate high memory IO in the Grafana database. Um, are there any business impacts? So we're saying that it's running in a good state. We have significant connection capacity available, so there's no real business impact at this moment. We get a query performance analysis. So this is where, like I was mentioning earlier, it's actually bringing the chart into the picture so that you can see the data for yourself. You can interact with the chart how you wish. You can filter it, you can slice and dice it, things of that sort. And then you have the query performance highlights. So we're seeing consistent performance. What are the peak activity periods? So we're saying that for this particular database cluster, the peak activity is during 10 a.m. to 3:30 p.m. UTC time, and it's not a lot because there's just some test workloads here. Then we talk about connection utilization and database workload. It does a connection pool analysis, a database workload distribution. So again, it's picking the different databases within the server, and it's talking about which database has the highest workload, which has the second highest workload, which database has a moderate load, variable load, etc. So of course, all of these things are things that you can look through the charts and find out for yourself. But for something that just takes a minute or two, it's really nice to have that summary ready and available. And for this particular example, there's no big issues happening. But if there were specific issues with some of these reports, then kind of getting a readout about it is always helpful. We do the same thing for buffer cache, for disk IO, the IO performance. And then here you can see that for database storage, distribution, and growth patterns, we actually have a table across the top databases. So chart, alarm processor, space room, insights, these are all names of tables. And you get the split on their size, what percentage of the total they contribute to, how have they grown in the last 24 hours. And there's also a priority based on which databases Netdata AI thinks are the highest priority. Of course, this is just based on what we see in terms of how much resources it's occupying and how active it is. We are working on a feature where you can provide more context about your specific infrastructure, your team, the way you do things to Netdata AI, so that, for example, you could then go in and say that space room database is the thing that's most critical to us, even though it's only occupying 1.8% of the total. You could still say that this is the most business critical thing to us, and Netdata AI would understand that. Right now, it's making its a best guess estimate. You can already provide this information in the report, so I could have mentioned it here in the report description, and it would be considered. But what we're working on is a way that you can do it once across your space or across the room, and Netdata AI would keep this information in context all the time. And there are 12 more DBs, but you can see that together they just contribute to 4%. So it's been kind of aggregated here. If there were any standout specifics about any of them, it would get called out separately. There's information about storage growth, lock management, resource utilization, database specific lock activity. And then finally, you have your performance assessment, because that's what you asked for, right? So you get what your assessment is, kind of a breakdown of the actions that you need to take, what you could do for capacity planning, strategic recommendations, etc. So in this case, the situation is pretty good, but there are still some actions that you might want to look into. And the idea with something like this, because the question was a very simplistic thing, is that you have all of this information in Netdata already, right? So Netdata collects more than 100 metrics every second, 100 different kinds of metrics every second from Postgres systems. But to make sense of all of it and to get the amount of information that this report gave you would take a long time. And it's something that, especially while you're troubleshooting an incident live, you might not have that time. You might be looking at a dozen different things. So let's say that you were troubleshooting a specific incident, and you just started, you have a concern that it might have to do with your database. You could just go there and ask a question about it, just like that. And then go and do your other stuff. Within a couple of minutes, you have the report. You can just take a look at it and see, oh, there's nothing of concern here. It's working fine. There are no anomalies. So I can rule out the Postgres database. So that's how I expect that this sort of troubleshooting flow would provide the most value. So that was one of them. I think we have another one here, to just for a slightly different use case. You can see that it was generated as a scheduled report. So let's look at the report description. So this was the ask. Create a report with the status of the CPU throttling of the pods in my Kubernetes cluster. So we're going to be analyzing the CPU throttling status across all the pods in the Kubernetes cluster and do the breakdown. So we have the time frame of the analysis. What is happening right now. So the cluster shows widespread CPU throttling with the most severe impact on Redis stateful sets in the infra namespace, consistent throttling on this other pod. And what is the impact of this? So the impact is sustained throttling at these levels can degrade application latency, it can reduce throughput, it can cause intermittent timeouts, especially for Redis back services and observability components. So there's a specific takeaway that Redis masters are persistently being throttled. So we've identified something that's specifically wrong about my Kubernetes environment. There's a cluster-wide CPU throttling overview here that we're looking at 70 different containers across different nodes and different namespaces, and this is kind of a breakdown of your pods by the severity of the throttling, and then we kind of go into the top throttled pods. Who are these pods? So you can see that it's related to Redis master. So the top 10 throttled pods, as listed here, are Redis charge master. Which node does it belong to? What is the throttling average? How long was it throttled for? What is the CPU usage average, the CPU limit percentage? All of this information. Again, you have this information in your dashboards, but it's spread across so many different charts, so many different dimensions, so many different metrics, that kind of getting it into this single tabular view would take a lot of mental gymnastics. But this is where Netdata AI really excels, being able to pull together something like this so that you immediately get to see that I have throttling issues, and it's specifically for these pods that I have it the most. So I can take decisions based on that. And it also goes further. So it goes into patterns and suspected root causes. So it's saying that the most important takeaway is that the dominant driver is misaligned CPU limit policy and possibly CFS period, rather than actual node CPU scarcity. So it looks more like a configuration issue rather than us running into our limits. And there's more information about that as well. So CFS quota period mismatch. And we're saying that the monitoring stack is affected here. We're running Grafana on that particular system, and its other Grafana components like Loki and Thanos are being throttled. And when it comes to the recommendations and the next steps here, it's again ordered by priority. So we're saying that Redis workloads, we should increase the CPU limit by 50 to 100% or remove the limits entirely to accommodate bursts. expect 70 to 90% throttling reduction and lower latency if you do that. You could do CFS coder tuning. You could, for cube cost, network cost, daemon set, you should audit and raise the CPU limits. And you should increase the Grafana CPU limit to prevent dashboard or query throttling. So these are very specific, discrete actions that have come about from a very simple question that you had asked. So again, this is something that might happen while you're troubleshooting it. So troubleshooting an incident could either mean you provide all of the context and you try to get Netdata AI to one-shot it, to troubleshoot it and find the root cause for you immediately. Or it could also mean that while you are troubleshooting the issue, you have these questions that pop up in your mind that, do I have throttling issues right now? Do I have database bottlenecks right now? And you can just spawn these reports while you're in your troubleshooting flow, and you'll get notified when the report gets generated, and you can just then quickly do a sense check and validate what's happening right now. So each of those actions, each of those steps would have taken basically many minutes, maybe an hour or more. But now you can condense those into 2-minute chunks that you could even run in parallel. You could just kick off multiple troubleshooting reports in parallel for different questions that you have. While you're looking at something else, Netdata AI is doing the work on that, brings it to you, and then you can make that decision for yourself. Right?
Sham, a quick time check. We have 10 minutes left on the
Okay.
webinar.
Yeah,
So
I'm done with the demo. So those are the two reports that I wanted to show you. I think we can go back. Let me just.
maybe I think before you hop onto it, I think, it was a great demo, but just for the audience to understand, AI is embedded throughout the dashboard on the data. So when an alert triggers, you have a quick button that you can press to troubleshoot the alert. If you are looking at some charts on the metrics tab, Netdata already has the context of what you're looking at, and you can initiate an investigation from there, but also create any kind of templated reports that Sham showed in there. So just a quick summary, because we couldn't get to the entire demo of
Yeah.
the AI feature. Yeah, go ahead, Sham.
So I wanted to touch upon some of the new features that we are currently working on that should be available soon, just so you get a little bit of teaser, a taste of what's coming up. So this is, the alert creation and alert configuration and alert editing is something that we get asked about all the time when it comes to Netdata's AI capabilities. And rest assured that this is the highest priority thing that we're working on. And you should be able to soon create alerts, edit alerts based on natural language prompts that you give. So if you have a simple request, you want to create an alert to notify you when a process dies, you can just ask for it, and we should be able to create it for you. Similarly, for the alerts that already exist, when it gets triggered, and sometimes you don't fully understand what the alert is about, or when exactly is it triggering, what is it trying to tell you. We have an alert explanation feature that's in testing right now that will explain exactly what this alert is trying to tell you, or even for alerts that haven't been triggered, it'll tell you what this alert would tell you when it triggers. You can also use this for the alerts that you create or edit yourself, so that you can be sure that the alert is indeed doing what you think it's supposed to do. And then again, staying on alerts, we're working on a mechanism to identify misconfigured alerts. So you could have alerts that are noisy, alerts that flap too much, alerts that you've silenced and just sitting there as silenced alerts. So most of this noisy alert or alert fatigue problem happens because there's no golden thresholds that work for everybody's environment. Everybody's environment is different. So you can always, Netdata tries to be opinionated we can come up with what we think is the right threshold for a particular alert, and it might work for the 80% of users out there, but it might not work for your specific environment because it's different. It has its own needs. So we should be able to identify alerts that are misconfigured for a specific environment. So just by looking at what's happening with the different alerts. So that's step one. And then step two is that once you identify the alerts that are misconfigured, can we suggest what the right alert should be? What the alert threshold should be, or which alerts should be enabled in your system to catch issues before they happen or before they become a bigger issue. So that's something that we think is very important. And then real-time chat is again something that's pretty high up on our priority list, because today what you can do with Netdata is you can ask for something like I showed you earlier, and then a couple of minutes later you get this detailed troubleshooting report. But sometimes you just have a simple question that you want to ask and you want to get an answer immediately. You don't want to generate a new report. So for this is where you have like a dynamic chat interface, and once that's in, you should be able to then use it in other places as well. So for example, the report that you just saw that broke down the throttling by the pods, maybe you have a specific question about one of the pods. You shouldn't have to create another report just to ask that. You can just ask that in context, in place. So that's the idea with the real-time chat. And then of course this is just a small subset of the features that we're working on. um, uh, we are also working on making the AI agent, the co-SRE agent that we're talking about. Can we give it more independence so that you can treat it as a team member and give it longer horizon tasks, right? So instead of saying, you know, find me the pods that are being throttled, or does my database have issues, you should be able to give it longer horizon tasks, right? Like go off and work on something for a week, right? Make sure that this particular service for which you've done a new deploy is working like it's supposed to be, and keep looking at it for the next 7 days, and report back to me if you find any issues. You should be able to assign tasks like that, and then also interact with the co-SRE agent in other tools that you use, like Slack or Teams, so that you don't have to bring all of the context yourself into Netdata every time you do something like that. So we're also working on integrations where you can integrate Netdata with these other tools, with your PagerDuty, with your GitHub, with your GitLabs, and things like that, so that Netdata would automatically be able to pull in other pieces of information as and when required, if you tell it to.
Yeah, I'm just putting on screen a question which was just asking about it, Sham. If
Yeah.
Netdata
So
AI can connect to other MCP
yeah, so this
servers.
is touching upon the point that I just mentioned. It's a good question. We're working on ways in which you can connect Netdata AI to other MCPs that you might be using for example, for GitHub, for GitLab, PagerDuty, and other tools that Jenkins, other tools that have context that will be useful for troubleshooting. That this is when a deploy happened, or this is the set of code changes that went in that preceded the outage. So information like that would be useful for Netdata AI to do the troubleshooting. Today, without it, it will try its best with the context that you manually provide, and then it would make best guess estimates in other places. But if it had a way to connect, and if you configure it like you do the alert notifications, then it should be able to do this today.
Thanks, Sham.
So
I think
yeah, go
we have just a couple of minutes
yeah, I
on
think
the clock. I don't know
yeah,
if you have any final words, but I think we must also leave some time for any questions. There are a
yeah,
couple in chat,
yeah,
but maybe I'll allow you to
sure.
summarize.
Yeah. No, I think we're done with the presentation. Of course, there's different roles and different places and different points in time where you could use functionality like this, and we're also learning almost every week new use cases that the community has found, that our users have found for Netdata AI that we didn't even think about. So it's you know, it's really completely up to your imagination about how you can use this. So I think we're ready for questions. If there are any more questions, let's take them. I'm sorry we ran a bit long, so we don't have a lot of time for questions anymore.
Yeah, but I'm going to put them on the chat. I think one of it is mostly to do with our title, and this is from David. Uh, I think it's a valid point. He says the AI is nice, however, this doesn't actually show me how to automate the first hour of an incident.
Yeah.
We
So
say with AI, but
yeah.
go
So
ahead, Shah.
I would say that what I was trying to say while I was doing the demo was basically this: that when you start troubleshooting an incident, you have a bunch of these unresolved questions in your head, based on your experience, based on your domain knowledge, based on what context you have. Um, Without the automation, you would either have to manually go and validate these things, which will quickly eat up that first hour, or you would not do it at all and you would just wing it. Basically, that you would assume based on your mental model that this is the most likely thing, which might be right, but which might not be right. So what we're saying with AI that you could do is that you don't have to leave that to kind of a best guess. You can just kick off all of these questions that you have in parallel if need be, or during that initial hour, so that all of those things get answered, so that by the end of the hour you have enough information to be able to, let's say, make a much more informed decision or a change or apply a change, uh, with without having, even if you're going to, let's say, you've decided that this is the problem and then I need to roll back or I need to restart this particular service, you can even ask that question of what is the impact that this change that I'm going to apply will have, right? And you don't have to wait a long time to get that feedback. So the idea is that you can just do this in a few minutes and then take a much more informed decision. So this is why we call it a hybrid approach, because it's not saying that the AI is entirely going to take over and do this for when you have an incident. It's basically saying you're still driving things, but how can you use the AI to just make things simpler or faster or quicker, right?
Thanks, Shyam. And just to add to that, David, of course, Netdata was always built as a troubleshooting focused observability solution. So even before AI, we've had, okay, it's not really automation, but we've had some extremely powerful tools like metrics correlation and anomaly advisor, which kind of gave you, let's say, a quick way of identifying the direction of your troubleshooting. So Netdata help you correlate all the metrics or identify all the metrics by sorted by anomalies, which in, I would say, 99% of the cases gives you the direction or potential direction of where your troubleshooting should go. And now with AI, of course, this webinar was more focused towards AI, but there are also other interesting tools that you may try out if you cannot make use of the AI capabilities. But just pointing out, I think David got confused because it said automating the first hour of troubleshooting, and we didn't mention AI in the title. But yeah, we do have also other tools. I think we have one other question, Sham, that came in. Let me quickly put that on the chat. Says, are the AI reports available on free community plan or self-hosted OSS? If not, how do I test them?
Yeah. So the for everybody who's signing up for a new Netdata Cloud trial, you should have 10 AI reports that you have to play with and experiment with. But if you're already on the community plan, we have been running for a few weeks this waitlist program where you just sign up, provide your information like your space ID. We would just bump you to a trial so that you have a chance to play and experiment with these features. Um, yeah, so if you want to try out Netdata AI and are not able to in any form or fashion for whatever reason, just reach out to us. You can reach out to us at product@netdata.cloud as well, and we'd be happy to find a way to enable you, because the more feedback, the better that we can make the capabilities.
Okay, I think we've come to the end of the webinar. I'm sure many of you still have any questions. Feel free to reach out to us at product@netdata.cloud, or even on Discord or on our forums, and we're more than happy to discuss with you or even book a meeting with us to know more about all of these capabilities that we were talking about. Uh, I think that's all we have. So thank you very much, guys, for participating. It was a longish session, but I hope it was useful. And thanks, Sham, for presenting.
Yeah,
I think
thanks a lot, everyone. Thanks for the patience for listening to me talk for, for an hour.
thank you, guys.
Thank
Have a
you.
great day. Bye
Bye.
bye.